Hello, sir. Good afternoon, everyone. I welcome all the participants to the third session of day one on online ATAL FDP on lean manufacturing industry 4.0 scenario. And also welcome Dr. N.M. Shivaram, Assistant Professor, Head and NIT, Karaikal. He is going to speak on lean manufacturing through total productive maintenance, TPM. I want to introduce Dr. N.M. Shivaram is presently an assistant professor and head of the department, Mechanical Engineering Department in NIT, Puducherry, Karaikal. Shivaram received his BE degree in Production Engineering from PSG College of Technology, India in 2008, MTech degree in Industrial Safety Engineering from NIT, Tiruchirappalli, India in 2010, and PhD degree in Mechanical Engineering in the area of Total Productive Maintenance from Anna University in 2014. He is having 8 years of teaching and research experience. His research interests include total productive maintenance, machine process, sustainable manufacturing, materials for energy applications, industrial safety, industry 4.0. He has more than 25 papers published in international journals and is currently conducting consultancy projects sponsored by Central Public Works Department, India, and Central Pollution Control Board, India. He is also part of planning and development division and involved in infrastructure development and maintenance at NIT, Puducherry. I welcome Dr. N.M. Shivaram for the third session, sir. Over to you, sir.
Sir, good afternoon all. Thank you very much for your kind introduction. So I am Dr. N.M. Shivaram, presently Assistant Professor and Head, Department of Mechanical Engineering, NIT Puducherry, Karaikal. First of all, at the outset, I would like to thank Professor Karthikeyan, who is a coordinator of this ATAL FDP, so for giving me this opportunity to share some of my knowledge with all the participants. And also, I would like to thank the management of Rajarajeshwari College of Engineering, Bengaluru, Karnataka, for giving me this opportunity, along with AICTE and ATAL scheme, ATAL FDP scheme, for providing this opportunity to present a few of my thoughts on lean manufacturing through total productive maintenance. So with that gesture, I would like to go into today's session. So basically today's session, the first part I have, like how I have planned the today's session is, the first part, I will just give you a small introduction about lean manufacturing. I hope all the participants had 2 sessions in the morning with regard to lean manufacturing. So one by Professor Dr. Devadasan. So he elaborately introduced you to the lean manufacturing process. So, but still, to ensure continuity, I would like to give a small brief introduction about lean manufacturing at the beginning. Then I would like to introduce you to the concept of total productive maintenance and the key elements of total productive maintenance. And after the discussion on total productive maintenance, we will see how a small roadmap of implementing this total productive maintenance in an organization, how this will help in implementing, or how TPM helps to achieve the goals of lean manufacturing, and thereby how it is also suitable for the industry 4.0 scenario. So this is how I have framed my lecture. And so with that small introduction, let me proceed to the session. I hope my slide is visible to you, and I'm just moving on to the full screen mode. So are you able to see the slide? Can I get a confirmation from the organizers?
Yes, sir. Visible.
Yes. I'm just moving on to the second slide. So my basic presentation is about the lean manufacturing through total productive maintenance. So that is my presentation. And so I have moved on to the second slide. I hope the second slide is visible to you.
Yes, sir.
Okay, thank you. So what is lean manufacturing? So at the outset, I would like to just give a brief introduction about lean manufacturing. So lean manufacturing, or sometimes it is also known as lean production. So basically there is a lot of difference between manufacturing and production, but production is what brings the entire manufacturing technology together, and also the production views the manufacturing technology from the point of view of the economic aspects. So production engineering is more about the economy of manufacturing, whereas manufacturing processes just discuss about the technology behind the manufacturing processes. So lean manufacturing is also known as lean production, and lean manufacturing is a series of methods. It is not a single method or a single uh, uh, defined model, so that you say that this is lean manufacturing. So it is not the case. Lean manufacturing is a series of methods, and it has its roots in almost all of the quality control tools. So any quality control tool you can utilize for lean manufacturing. So it is basically, you cannot define lean manufacturing into a single system. It is a combination of methods. It is a series of methods, first of all. So you have to, you can choose whichever tool which is readily adaptable to your scenario. So that is the beauty about lean manufacturing. So it is not actually a defined paradigm. It is actually a series of methods. So that is the first understanding we should have about lean manufacturing. And basically, lean manufacturing, as the word suggests, lean is nothing but you have to keep it as minimal as possible. So when you take the case of material usage in your organization or in your process, when you take the case of labor in your organization, so everything has to be at the minimum level, or you say the optimum level, so that your entire process is effective and also your process is very efficient also. So lean manufacturing, as the name suggests, it is a series of methods which is designed to minimize the waste. And the waste can be in a material, it can be in the form of labor, it can be in the form of processes. So whatever it may be, you have to reduce the waste. So, or reduce or minimize the waste. So that is the first objective of lean manufacturing. And when you reduce the waste, you always talk about increasing the productivity. So when you can reduce a waste by giving the same output, or when you can increase the output, so you can say that with reduced input, I'm getting a same or increased level of output. So in that case, you can say we have an increase in the productivity. So that is how productivity is also related to lean manufacturing. So basically, lean manufacturing is to reduce waste, to keep things as minimal as possible, and also to ensure the process is effective and efficient. So this is the simple philosophy behind lean manufacturing. And lean manufacturing, it has its origin in Japan, in the form of Toyota production system. So in Toyota production system, when it was actually implemented, it was not known as a lean manufacturing principle. So it was just a just-in-time production when it was implemented in Toyota production system. Toyota, they are a very big automobile manufacturing company. So they are one of the front runners in implementing many of such productivity increasing programs. So in one form of that is the just-in-time production system. So basically, lean manufacturing is related to the just-in-time manufacturing system, where the just-in-time manufacturing, the predominant idea was to keep the inventory as low as possible. So when you keep the inventory, so it is nothing like you operate with zero inventory. You operate with inventory with an amount which you want only at that particular point of time. So you don't store your inventory. At the same time, you don't make your process waiting for the inventory. So as the process proceeds, the inventory should come. That means inventory, in the sense, it is the raw material. So see, as simple as that, you can say it is a raw material. But inventory is of three types. So one is the raw material inventory, which is your basic raw material which is available for the manufacturing process to proceed, then you have work in process inventory. They call it as WIP. So work in process inventory is the inventory which are under process. So for example, I'm manufacturing an automobile engine. I'm manufacturing an IC engine block. I'm doing all the sorts of machining. So whenever the raw material is lying, that is a raw material inventory. Whereas when I just start a process on that raw material, then it becomes a work in process inventory. So it is considered as work in process inventory unless your processes or your processes are over on that particular component. Then you consider it as a finished goods inventory. So your goods is completed, your manufacturing processes are completed. It is remaining as a finished good to be dispatched to the specific locations or for the applications. So in that way, you can categorize the inventory. So inventory is basically your material. So inventory is basically your material, and your inventory should be present just in time for your manufacturing process. So this was the initial philosophy that was proposed by Toyota, and this forms the basis for your lean manufacturing principles. And later, lean manufacturing formally it was introduced, or a book on lean manufacturing. The first book was known as The Machine That Changed the World, and this book is what details about the lean manufacturing principles. So overall, from this, you can understand that lean manufacturing is about eliminating waste that does not add value. So it is very simple. The definition is very simple. Lean manufacturing is about eliminating or reducing the waste that does not add value to your process. So that is the best way to explain lean manufacturing. And by eliminating such waste, you are producing or you are providing the best possible product to the customer, and you're not also compromising on the efficiency of the or effectiveness of the product also. So that is about that is the lean manufacturing. So with that, I'll move on to the next slide. So so basically, lean manufacturing, you can see you can see that lean manufacturing is all about reducing waste. It is like to reduce the waste, which is known as mudas. Mudas in Japan, that is known as muda. They simply call it as muda in Japanese term. So basically, in earlier, the waste are divided in or categorized as seven lean manufacturing waste. But now of late, one more component is also added to that. That is the latest 8. So so the 7 waste are listed as such. So first you say inventory. That's what we discussed in the earlier slide. So how the Toyota production system started the just-in-time processing for managing the inventory. So inventory is the first waste. Then waiting. So waiting in the sense your raw material or your inventory is waiting at a particular location without being processed for a longer period of time. So your inventory has to be properly scheduled so that it is processed at the right time. So it should not wait. So when an inventory waits at your location, it becomes a waste. You are actually paying for it. You are indirectly paying for it in terms of your interest or your capital asset. So whatever it may be. So waiting is a waste in the manufacturing line. Then defects. So defects is also, it is a waste from a product. So it is like you manufacture a product, it does not meet the specifications, so you want to rework it. So that means again your reworking time is adding on to the product cost. So that becomes another waste. So that is about the defects. So when there is a product with some defects, you have to either reworked, or it is again totally scrapped out. So once you scrap it out, it becomes a scrap, and again you have to build a new product. And so defects is a waste. Then overproduction. Overproduction is again, you are putting all your resources, you are manufacturing certain components, and you do not know the actual demand in the market. You overproduce it. So in that case, you are actually losing all your resources as a finished goods inventory. It remains in your premises as finished goods, and it doesn't make any use. It doesn't make any revenue. So overproduction is another waste. And motion. So motion, again, you are even a small movement in the organization. Either it can be a manual movement, or it is a machine movement, or the movement of inventory by manually or by some machine. Everything involves cost. So you have to move your product only for the minimum distance. So you would have come across this transportation related problems in your operations research. So mechanical engineers, you might be knowing it. So operations research, we have the transportation related problems. So where the minimum most distance traveled is what preferred. So any unnecessary motion also adds to the cost of the final product. Then transportation. Transportation, again, you take the case of a supply chain. So supply chain, now people are working on to optimize the paths or optimize the route. So basically, you can see now, you take the case of this commercial e-commerce products. So you are ordering online, you are getting the product from one particular hub, and from that hub, the vehicle is routed through certain route only. So for example, when I'm sitting in Karaikal, I usually get the products from either from Salem hub or from Chennai hub. So these two are the hubs that is very near to me. Even though I get the product from Bangalore, the product from Bangalore will come to Salem, and from Salem it will be routed to Karaikal. So basically, they have predefined routes. So they have found out that transportation is also adding to the cost. So they have fixed routes, and any change in the fixed route will require some real analysis, so that your costs are always kept low. So that is the idea behind just to reduce the excess transportation is also considered as a waste. Then over processing. So over processing, again, you have to produce the product only for the specification. So for example, I take the case of IC engine again. And the IC engine, the external surface, it doesn't matter. So the surface roughness of the external surface of the IC engine, it doesn't matter. It doesn't have anything to it doesn't have anything related to the product performance. Whereas the combustion chamber that is present inside the IC engine is where your entire product performance is actually matters. So you should always think, so where my specification my product should be processed only for the application, not additionally. So for example, you can, in the case of machine drawing, you have all your drawings, your product drawing, your part drawing, your assembly drawing, and each and every product or each and every part in the machine drawing, they will identify or they will mark. So this surface has to be heat treated. This surface has to be is to have so and so surface roughness. This surface has to so and so. It has to have the surface lay pattern. So in what type of lay pattern it is being preferred. So all these things are defined in an organization. So over processing. So I don't want to do any extra processing. So if I do an extra processing or over processing, then it is considered as a waste. So these are the 7 traditional wastes that are considered over a period of time. And now the latest, people have added the unused talent. So unused talent in the perspective of the human resources. So any people who are not given the task or the challenge, which is mapping with their talent, then if people are not working to their particular level, then you can consider that it is an unused talent, and the unused talent also becomes a waste, because you are not working to your potential. So that is another waste that is being considered from a human resource point of view in the latest days. So this is about the basic 7 waste, or the plus additionally the unused talent, so which is considered as a waste.
Hello, sir.
Or in the yes, sir, I can hear you, sir. Hello, can you hear me? Can you hear me? Can I proceed? Okay, thank you. So these are the 7 waste, or the waste that is considered in lean manufacturing. So waste, it is also known as muda in Japanese. So people also say it as mudas of manufacturing. So this is for just understanding about the waste. And moving on to the next slide, slide number 4. So when you talk about lean manufacturing, as I told you earlier, it is not defined. It is not defined within a single method, or it is not a single process. So it is a series of methods. You can achieve lean as in a series only. It is not that you just execute this, you just implement TPM and you say that I'm lean. It is not so. You have to have multiple processes or series of methods to be implemented, and only then you can have, or you can say that I am towards achieving a lean manufacturing paradigm in my organization. So in that way only we can say that we are following lean manufacturing. So it is not a defined in a single basically it is not defined in a single module. It is a series of methods which are to be implemented, so that you can say that you are moving towards lean. So these are the various known methods of lean manufacturing. So first I will start with line balancing. So it is just, I wanted you to introduce. I'm not going to touch about all these methods except TPM. So TPM is our scope today. And so line balancing, so you can see that assignment of right number of workers and machines. So it is basically you are scheduling your operation. So you are assigning right number of workers and right number of machines. So in that way you should be always ensure that the workers does not overexert themselves, and also they are not free for a significant period of time. So you should give them the work for their planned time, including all the breaks. Similarly, the machines also, based on the maintenance schedule, based on the capability of the machines, you should load the machines so that the line balancing is always followed. So if you follow that, then you can always ensure your organization is working at the optimum level. You are not overexerting, you are not underperforming, you are performing at the optimum level. Then value stream mapping. Value stream mapping is a set of methods. It is basically used to visually display the flow of materials and information. So it is a graph. So it actually visually it shows from which point to which point the material flows and how the information is flowing. So the value stream mapping, the major agenda of value stream mapping is to identify the value added activities and identify the non-value added activities and remove them from the operations. So that is the necessity of implementing value stream mapping. And single piece flow is a lean manufacturing concept. Usually we have seen when we talk about industrial engineering practices, you have mass production, you have discrete production, you have continuous production, in the case of, say, for the case of chemicals or the bulk materials. Whereas generally we say that batch production is always good. That's what our assumption is. But still, if you can still reduce the waste in the batch production also, you can go for the single piece flow. So single piece flow is nothing but one product is produced and the one product is alone concentrated, and only that particular product is completed its operation, it moves to the next stage. So stage by stage, only one product is concentrated. So if that also reduces waste, but this again has some questions, because when you talk about batch production is also efficient. So again, practitioners have to find a right way or right balance between the batch production and the discrete production on the single piece flow. And coming to 5S, so any productivity improvement program, this 5S is one of the basic necessity. So it is like our normal day-to-day life, we require good housekeeping, right? We want our house to be kept in a proper way. We want our office to be kept in a proper way. And similarly, in an industry or in an organization, if you have everything arranged in a proper way, then it is always easy to improvise on that particular aspect. So it is always easy. The productivity is always improves when good housekeeping procedures are followed. And this was identified by Toyota Production System, and they introduced the 5S concept. And 5S is a method for improvement by exposing the waste and poor utilization of resources. So you can see the 5 steps: the sort, set in order, shine, standardize, and sustain. Again, further we will discuss in detail when we discuss about TPM also, because TPM is actually based on this 5S. And just-in-time production, as I told you earlier, it is one of the first methods of inventory management that was followed in the Toyota production system or the Toyota system. So that is actually the basic route for lean manufacturing. So just-in-time is nothing but you are ensuring minimum amount of inventory. So you are not storing more inventory. At the same time, you are not ensuring you are not having inventory. And sometimes without inventory, you may not be able to do the process. So it is a balance. You should have minimum amount of inventory for your process. And that is the just-in-time production. And Kanban system is just an advance or just an additional support to the just-in-time inventory system. You can see Kanban is a visual information system which is established to maintain the discipline of widget. So Kanban is more like a display. So your entire process is put on a display, and where you require inventory, where you require what inventory, everything will be in the display system. Earlier, the Kanban cards were used. Earlier, before the advent of all the display units, now people started using very large display units in their screen, in their premises. So what they are producing, what they require, everything will be displayed on a large screen, and the people will be working with respect to that. So if they want, they will be knowing what is required now, what is required after 1 hour, what is required after 2 hours. So people will be planning for that. So Kanban is a visual information system which complements the just-in-time production system. And another thing is SMED, the single minute exchange of die. So single minute of exchange of die is also used in TPM. So basically it is you are putting a restriction on the changeover time. So if there is some maintenance, if there is some break or production break, so or if there is some say for example, you are changing the specification of your product, you want to change the setup of your manufacturing system. So everything, all these changeovers has to take place within the time frame of less than 10 minutes. So it is a single digit minute. So single minute means it is a single digit. So from 0 to 9 minutes, you should be able to do all these changeovers. So that is the maximum time available. So that means you are putting some cap so that people will work towards that, and whatever the break time or whatever the changeover time required will be less than 10 minutes. And finally, you come to TPM. TPM is a holistic approach to equipment maintenance, which always strives to improve or achieve the perfect production. So today we will be discussing more about TPM. But as I told you earlier, lean manufacturing is basically a series of methods, and you have these are some of the examples. And in each and every concept, each and every concept like line balancing, value stream mapping, single piece flow, whatever the quality control tools is adaptable or it is applicable, that is very much welcome. You are not restricting anything in lean manufacturing. Whatever is capable of reducing the waste, whatever method or whatever process which is capable of reducing the waste, you are definitely welcome, and it can be incorporated into the lean manufacturing system. So that is the basic understanding. So now we will move on to the total productive maintenance. So this is a simple introduction about lean manufacturing, and now I move on to this topic of discussion for today, that is lean manufacturing through total productive maintenance. And before going to the relationship between total productive maintenance and lean manufacturing, I would like to introduce you to TPM concept first. So TPM, the expansion is total productive maintenance, and it is basically a maintenance philosophy. So since the word maintenance is present there, it is basically a maintenance philosophy which is used to increase the productivity. And the word total here means it is you are involving the entire organization. So that is the meaning of total. So total is nothing but you are involving your total manpower or your total human resource that is available in an organization. So the word total, it is very similar to the total quality management. In total quality management, similarly, you are involving all of your organization's members towards achieving quality. Similarly, in total productive maintenance also, you are involving all your man-force or human resources to increase the productivity through appropriate maintenance practices. So TPM is a holistic approach to equipment maintenance. The holistic means is the total. So it is you are just involving everyone in the organization. You are not only the top in certain philosophies. Only the top management will be involving, or middle level managers will be involving them in creating the strategies or defining the practices. But here, in the case of TPM, you are involving even the lower level workers also to have their say in maintaining the equipment, because without their involvement, you will not be able to achieve anything in an organization. So TPM is a holistic approach to equipment maintenance that strives to achieve perfect production. Perfect production in the sense your machines are available 100%, your performance is 100%, the machines are performing at 100%, and the product quality is also 100%. So that is the perfect production. So perfect production in the sense it is not only the product quality, it is also about the availability. So your machine should be available 100%, and 100% performance should be extracted from the machines. So that is the perfect example for perfect production. So no breakdowns, no small stops or slow running. So you don't you can have planned stops, but unplanned stops should be avoided. So that is the basic idea about this small stops or slow running. So obviously any machine requires some basic maintenance, and there is some planned time for that maintenance activity. So that is also is a part of TPM. And TPM emphasizes on no defects and no accidents. So it also includes one more component of creating a safe working environment, because when the working environment is safer, when there is no accidents, obviously it is going to increase the productivity, because accidents, it will reduce the production time, it will reduce the productivity rate. Also, it will create some legal issues to the organization. Again, some indirect costs are involved, because you want to pay the labor or workforce who is victimized in an accident, and also you are supposed to do all the necessary what do you call it? Insurance schemes are there. You should be able to pay for that, and also you should compensate the employees based on the accident and based on the injury level. So TPM also focuses on creating a safe working environment. So it is not only ensuring machines to work at 100% availability, 100% performance, and also 100% defect free. It is also focusing on creating a safe working environment, which will reduce or which will eliminate the accidents. So TPM is actually a proactive and preventive maintenance philosophy, which is used to maximize the operational efficiency of the equipment. It reduces the distinction between the roles of production and maintenance people. So this is what I meant. So it involves all the people in the organization. So in some cases, the production person who is the operator of a machine may be reluctant to do a basic maintenance for the machine. But that is not the case in TPM. The operator has to do autonomous maintenance. So basic maintenance all will be taken care by the operators themselves. Then only the critical maintenance or a large scale maintenance activity will be taken care by the maintenance personnel. So which will allow for a seamless working environment. You can have more working hours if the operator itself takes care of small maintenance issues. So that is the point I want to make here. And the implementation of a TPM program creates a shared responsibility. So it is the responsibility for all the workers. It is not I'm doing this particular operation, I'm responsible only for this machine. It is not the case. So each and every employee is trained for all the activities in the shop floor. So that is another highlight of this program. And when you can have all these things, when you can have all these things in your organization, then you can say that your organization will have a good productivity, which means increasing uptime in the sense the time of production, reducing cycle times. So cycle time is the time taken for producing a single product. So you can reduce the cycle time. So once you reduce the cycle time, automatically your available time is going to be increased. So you can even produce. If you have the demand, you can produce more. And eliminating defects. So eliminating defect also increases productivity. So this is a small introduction about TPM. And the origin of TPM, as I told you earlier, it originated in the form of JIT in Toyota Production System, but Japanese Institute of Plant Maintenance was the first organization to define a TPM philosophy, and it was defined or proposed in the year 1971 by JIPM. So Japan Institute of Plant Maintenance. So they are responsible for this creation of this TPM philosophy. And TPM is actually focusing on the equipment and people, and it's a maintenance method which improves productivity to have zero losses. So losses is very important here. So where the losses are occurring, you can, in TPM, they call 6 big losses, and the how to address these 6 big losses. That is the prime motive of total productive maintenance philosophy. So it was actually developed by Japanese Institute of Plant Maintenance. Earlier, you can see these are the maintenance methods that were followed. Before 1950s, we call it as a breakdown maintenance. So only when there is a breakdown, people will think about that, oh, this machine has to be maintained. So if there is no breakdown, people will never think that this machine has some wear, it will have some wear, it will have some life. So people never thought about that. So only when there is a breakdown, people say, okay, that this machine has stopped working, we have to do what? We have to rectify it. So this was the approach in before 1950s. And slowly then people understood that, okay, when there is some breakdown, it is costing us a lot. Our production is stopped. Our resources are lying unutilized. Our inventory is lying unutilized. So then people thought about the preventive maintenance in 1950s. So preventive maintenance is, in the sense, people then start, based on their experience, they started to note down, okay, so these are the critical issues in a particular machine, and we have to prevent all these critical issues. So based on that, they developed certain strategies. So they applied this preventive maintenance for a certain period of time, and then people called something an extension of preventive maintenance as productive maintenance. So people they thought, okay, even preventive maintenance is not effective. They wanted to think proactively. So preventive maintenance is also proactive, but people were not satisfied with that, and they wanted to think more. Okay, what are the failure conditions, or what are the failure a machine may undergo? So people started to think about that, and what is the frequency of failures. People started to estimate those things, and they prepared plans to overcome those maintenance issues. So that was the productive maintenance. And in 1971, put together all these philosophies, people also involved or understood the involvement of the operators also. So whatever in the paper, if it has to be implemented in the shop floor, the operators are the key personnel. So their cooperation is very important, and that's why the word total has been introduced there. So total productive maintenance is the involvement of all the personnel, right from the top level management to the bottom level workers. All has to involve, and such type of productive maintenance strategy becomes the total productive maintenance. So TPM is actually an overall maintenance for manufacturing, and this overall maintenance involves all the employees of the organization. And moving on to the next slide, slide number 7. So with that, in 1971, people or Japanese Institute of Plant Maintenance, they introduced this TPM concept, TPM philosophy. So an 8-pillar TPM philosophy, which is solidly based on the 5S concept. So this is what I told you earlier. So even the base for a TPM product or TPM program is a 5S. A good housekeeping is necessary for implementing a quality improvement process. So you should know, you should have your process, or you should have your organization. It should be properly aligned. It should be properly defined. Only then you can create whatever the quality improvement paradigm may be. Only you can implement only when you have a good housekeeping or good 5S concept in place. So TPM is basically a 5S as the foundation, and 8 supporting activities that are referred to as pillars. So each and every pillar is an activity. So in each activity you have sub activities. So all put together, we call it as the total productive maintenance. So this is the basic 8-pillar model that is very famous. That is very most every one of us know about this 8-pillar model of TPM. Even though it was actually implemented in the year 1971, it was actually developed over a period of time. In the 1960s, this philosophy started to develop, and finally in the year 1971, it started getting implemented in Nippon Electrical Equipment, currently the Denso Corporation in Japan. And so to start with the first basis of TPM, you can see that it is the 5S is the basis of TPM. So you can say that 5S is the basis for any quality management program, and the 5S is in Japanese. You can see this Seiri, Seiton, Seiso, Seiketsu, and Suzuki. And this is to be for better understanding. In English, it is known as sort, straighten, shine, standardize, and sustain. So sort is you eliminate your unnecessary requirements in your work area. So you need to have, you first you have to sort it out. So which is value adding to me, which is not value adding to me, and that you have to clearly understand. Then you go for straighten. Then you basically you organize. So you just create some categories. So say for example, I'm having machining processes. So I'm sorting out what are the machining processes needed, and this time I'm just making all the machining processes under one category. Then there is some drilling process, or there is some heat treatment process. So I'm just categorizing everything. So whatever data I need, about any process, I can just go to that particular block. I can take the data. So it is more like segregating. Even we have done most of our accreditation work. So how to segregate files based on the various criteria that is accreditation is wanting. And shine, then you clean and inspect the work area. You clean your work area, you inspect the work area. So it is more like an autonomous maintenance. The operator himself, before start of the day's work, he just cleans and he just looks for any small maintenance if required. So say there may be small oil leaks in the machine. There may be some nuts or fasteners that are loose, and there may be some loose connection. There may be some electrical loose connection, or there may be some problem with the safety device. So all these things the operator has to come and look it into, so that he can report directly. And standardize, then you create standards. So as far as this process is concerned, this is the standard I want. So you start to standardize your operation, then you sustain it, you continuously you develop it. So basically it is the first four are the key process. Then you want to sustain this. So once you create a benchmark, you should not come below the benchmark. You should always try to improve continually. So why you need this 5 Ys as the base for TPM? Because in a clean and well-organized work environment, it is always easy to spot the issues. So when the environment is clear, then I can always see, okay, if there is some fluid leaks, there is some material spills, there is some unexpected wear. Usually even the operators will, by listening to the sound of the machine, they will know, okay, this machine is going to have some problem or some issue in the near future. So how these things can be achieved? Only when you have when you can remove all the unnecessary aspects from your work area. So you have to focus only what is needed in your work area, and you have to keep only what is needed, and you have to keep that in an organized manner. So it will be easy for you to identify any issues, and once you identify the issues, then it is always the starting point to overcome any problems. So that's how 5S is always the basic for TPM. And coming to the pillars of TPM, so the first out of eight pillars of TPM is the autonomous maintenance. So autonomous maintenance, as you can see, it is earlier days, the operators and maintenance personnel were exactly like two different poles. So the operator will say the maintenance is the work of a maintenance personnel, whereas the maintenance personnel will say the operator has to involve with himself or the maintenance personnel, because the maintenance personnel may be involving in critical maintenance activities also. So to overcome that, TPM proposed the autonomous maintenance pillar. So it is actually involving the operator to carry out all the small maintenance issues that is occurring or that is arising in an equipment. So it places the responsibility for routine maintenance such as cleaning, lubrication, and inspection. And all these routine maintenance are taken over by the operator. And once operator takes over all these routine maintenance activities, then the maintenance personnel will look into the activity which are highly critical. And once you look after both the routine maintenance and also the critical maintenance activity, then obviously your available time is going to increase. The machine is going to be not, the machine is going to break down only for a small period of time. And that also you can predict when the machine is going to break down. So all these things are properly organized. So the operator comes to the machine at the morning, he does all the routine maintenance. So there is some specific time allocated. So only after that he starts the machine. So there is always a scheduled maintenance that is taking place. So once you schedule your maintenance for your machines, then automatically your unexpected breakdown, the chances of unexpected breakdown is going to come down. So that is how this autonomous maintenance pillar is one of the core pillar of TPM activity, because it gives the operator the ownership of the equipment. Because you just give the responsibility to a person, the person will always try to do his best. So it gives the operator the ownership. It increases the operator's knowledge of their equipment, because the operator has to know everything about the equipment, because unless he works in the equipment, he will not know what is wrong or right in the equipment. So it is always a good thing that autonomous maintenance trains the operator to know the machines also. Then ensure the equipment is well cleaned and lubricated. You can see perform cleaning, lubricating, tightening, adjustment, inspection, readjustment on production equipment. So everything it is scheduled or it is planned earlier. So these things will take time to formulate. But once you have set all these things in your organization, automatically the machines are going to work, or the scheduled maintenance activities only will persist. The unexpected or breakdown will always be reduced. And also by practicing this, the operator also will know that when you can expect a failure. And once the operator know that this is the time there is going to be a failure, and the organization can be proactive, they can plan for the failure and they can schedule their maintenance before the failure, so that both the operator is also safe, both the product is also safe, and you are also reducing the breakdown or your unavailable time for the machine. So that is how this autonomous maintenance pillar works. And moving on to the next pillar is the planned maintenance. So this is again a continuation of autonomous maintenance. So you should always have a plan for your maintenance activity, because when you don't plan your maintenance activity, then you cannot plan for your available time, because you have to schedule maintenance. Either it can be a predictive maintenance, you can predict based on the reliability curves, based on the reliability of the components, because all the reliability data will be provided to you by the manufacturer. So you will know, so this is the working time for this particular component, and I can expect a failure in this particular component after this so and so period. It is just like maintaining our own vehicle. So we are maintaining our own vehicle after a specific period. We want to change engine oil, we want to change small components within the specific time period, and also we should at least take our vehicle to the service station, so that people will inspect and will tell you, oh, these are the things wrong with your vehicle and you are supposed to change. So it is similar to that planned maintenance. Maintenance has to be planned. It is always the best way to have your TPM philosophy implemented, because if you don't plan your maintenance, then you do not know when the breakdown will come, and you do not know also how long the breakdown is going to exist, because you cannot lose time by simply not running the machine. So you have to plan your maintenance, and scheduled maintenance is very important. It is done based on the predicted or measured failure rates. All these data are available from the equipment manufacturer, and by experience, the organization also have the data. If I take the case of an engine oil, so I should replace after some 3,000 kilometers. That is what the data given by automobile manufacturer. 3,000 kilometer or 5,000 kilometer, whatever it may be. Similarly, you have data for each and every component. And this scheduled maintenance or planned maintenance will reduce the unplanned stop time. So planned stop time is always better than the unplanned stop time. And most of the maintenance can be scheduled when the equipment is not under production. So that is also another good thing about planned maintenance, because you can, if there is an 8-hour shift, you can plan your maintenance after your shift also, and so that your shift is not getting disturbed. So in such a way you can plan the equipment maintenance. But that is possible only when you have a clear understanding about the machine, and reduces inventory through better control of wear prone or failure prone part. So you can always categorize the parts into two different types. One is wear prone, one is failure prone. So wear prone, gradually the wear takes place on a component and the component becomes unsuitable for normal operation. Then failure, suddenly there is a breakage of the component or sudden failure, and you have to reduce the time period for of such breakdowns. So you can categorize. So all wear prone products, you can know the time. So this is the time before which I want to change my component. Say for the case of automobile tires. So tires, you know that when it wears out, by visually inspecting itself, you can change the tire. So that you do not mess up with any breakdown. Similarly, failure prone product. So in industry, there are a lot of testing is there, non-destructive testings are there, and the operators are inspecting the components. There are some non-destructive inspection methods are also available. Even that's what I told. Even by the sound of a machine, the operator will know whether there is something, some fault is there in the machine or not. So in such cases, you can divide your products into two: wear prone product and failure prone product, and accordingly people plan their maintenance activity. And planning efficient and effective preventive maintenance and predictive maintenance. So preventive maintenance is, I am expecting these are the failure modes, and I am supposed to establish a system for prevent the unnecessary maintenance activity. Similarly, predictive maintenance. So predictive maintenance will come over a life cycle. So once a machine is running in a factory, so based on the experience, you can predict, okay, at this point of time, this may be a small issue may come in the machine. So it is always about experience, this predictive maintenance. So check sheets have to be developed. So generally there will be check sheets. So even when you go to the automobile service center, there will be check sheet. They will be checking whether engine oil has to be changed or not. Gear oil has to be changed or not. So in such a way, you can always categorize your key components, and all the components, their frequency of maintenance, everything can be put in a check sheet, and this check sheet will always help to effectively run your machine with the reduced or with the planned breakdowns only. I repeat, planned breakdowns is always good. Unplanned breakdowns is what reduces your machine availability. Then improving the critical maintainability factors. So you can see the two critical maintainability factors, MTBF and MTTR. So if you take a component, how long it takes between the failures. So between failures, what is the time the component is available for functioning. Similarly, mean time to repair, how long the component takes to repair. So always the MTBF should be as maximum as possible, and MTTR should be as minimum as possible. So over a period of time, when you have all the components, you will have the data for this. And once you have this data, you can always plan for your scheduled maintenance. So I know that this is the time for mean time between failure. So whenever the component is approaching at that particular time, then I can change that particular component. And this is how the planned maintenance pillar works in TPM. And moving on to the next pillar is the quality maintenance, or it is very simple. you try to identify the issues with your operation. You try to detect the errors, prevent into production process. So basically it is more like a root cause analysis. Quality maintenance uses the 7 quality control tools. So quality control tools are very much useful here. It can be a Pareto chart where you can know which failure is contributing a lot, and it can be a QC tool like root cause analysis. It can be a FMEA, or it can be a 5S system. So any 7 quality control tools can be placed here in the quality maintenance. So it is basically to know what are the root causes for a particular problem. So for a particular defect, quality defect, what are the root causes? And this again comes from experience, and also people sitting together and sharing their experience and note down when a failure occurs. You have to sit and analyze, and there will be a separate team for this. So when a failure occurs in the machine, you have to sit and analyze, okay, this is what was wrong in the machine, and because of this there was an unplanned downtime, and all these things has to be recorded, so that when you proceed further, these things can be avoided. So specifically targets quality issues with improvement projects focused on removing root sources of defects. So what is the root cause? So you know that there is a defect, but what is the root cause? That is more important, because you should always think about improving a process only from the root. You cannot just do it on the surface level and you can say that your problem is over. Because in safety, generally there is a saying, you try to eliminate the hazard. That is the best possible way. We are talking about this COVID times, right? The best possible way is not possible. We cannot eliminate coronavirus. That's why we are going for other different methods like social distancing, wearing mask, and other administrative controls like measuring temperature, all those things. But the best thing is to eliminate the root cause. And for that root cause identification, you have different quality control tools, and one such is the fishbone diagram. And with this, you can identify the defects early, identify the root cause, and reduce the root cause, thereby reducing the expenses that is taking place. And once the root causes are identified, you try to bring the defects to 0 level. So that is the objective of this third pillar in TPM. And moving on to the fourth pillar, again you can see the fourth pillar is about the focused improvement. So it is more like specifically there is a team operating in your organization. There is specifically a group of personnel. They'll be sitting together, they'll be analyzing. So even the third pillar, quality maintenance and focused improvement, almost there looks similar. So a small group of employees work together proactively to achieve regular and incremental improvements in equipment operation. So that is the job assigned to them. So you can have a separate team in the organization that what is the problem. So you should not always approach the problem from the sake of complaining. You should always see that, okay, there is a problem we should overcome, and we should not play the blame game. We should not blame others. Okay, he has done the mistake and we are not responsible for that. That should not exist in an organization, and that is always applicable to TPM. And that's why a small group of employees are always working together to proactively monitor their entire process and to achieve or to implement activities to have real-time improvements. And this small group of employees are known as cross-functional teams, because teams should be cross-functional always, especially this particular team, because a person from operation should be present, a person from maintenance should be present, a person from inventory or your stores should be present. So only then you can have a collective decision, or you can understand where the problem is. When you have a team from the same domain like operations, so people will think only from the operation point of view. People will never think from the maintenance point of view, or people will never think from the other inventory point of view, and so on. So this is why the emphasis of total comes into picture. So total productive maintenance this is the real total productive maintenance. You are involving all the members of the organization in the to have a say, or to involve themselves in improving the productivity. So cross-functional teams are present. Then the main job of this focused improvement pillar is to identify the 6 big losses. We will see a bit later what is 6 big losses. After we complete these pillars, we will see what are the 6 big losses in our organization. And 6 big losses are to be identified, and they are to be eliminated. And you can use any tool, any quality control tool, or as I told you, lean manufacturing is a series of methods. You can use any tool which is available for you. And most common tools which are used predominantly are YY analysis and FMEA. So YY analysis is a very simple tool. You ask 5 whys. Generally, there is a theory. You ask 5 whys for a question or for a problem statement. When you ask the 5th why, you will be ending up with the answer or the solution. So that is a general structure, or that is the general belief, or that is a practice that is existing in organizations. So to take the problem statement, there is a belt in the main transmission drive snapped in the grinding machine. So the belt is snapped in the grinding machine. So why did the belt snap? There was a heavier wear and tear despite short usage period. So the belt was used for a short period of time, but where there was heavy wear and tear. And why there was heavy wear and tear? The coolant carrying grinding mud drips on the belt. So the coolant is actually dripping on the belt, so that it is making the belt wetter. And once the belt is becomes wet, it becomes weaker. And that's why the belt is getting snapped. And why does the coolant drip? The coolant chute leading from the grinding table to the sump is not big enough. So the coolant chute or the coolant line is not big enough, and the coolant overflows. And the coolant pump capacity, and why is the chute not big enough? The coolant pump capacity was increased to accommodate high feed of jobs. So the coolant pump capacity was increased, but whereas the coolant chute capacity was not increased. And why the chute modified? Why wasn't the chute modified to accommodate higher flow? So when you increase the pump capacity, you should also increase the all the components capacity also. But why that was not added? That was a design flaw. It was a mistake by the designer. So by this way, when you ask 5 whys to a problem, you will get the final solution at the end of 5th why. So that is a theory in the quality improvement paradigm, that this is YY analysis is a very strong tool. And with that, you understand that design was problem, and with that you can change the design or redesign your component. And FMEA analysis, the failure mode and effect analysis, is another common tool where you identify the failure mode. If the product is failing, if there is a failure in a component, you identify what is the failure mode and what is its effect. So failure mode and effect. So there is always a saying that you should always look into problems which are creating which are responsible for more portion of losses. So in the Pareto chart, you can see very few problems will be contributing for a lot of problem, or will be contributing significantly, whereas very few problems or more number of problems, you can see 10 or 15 issues will contribute only to a 10% of the problem, whereas 1 or 2 issues will contribute to a 90% of the problem. So you want to focus on the issues which are very much influencing your activities. So that in that case, FMEA is also very similar. You are identifying the failure mode and you are identifying the effect. So how severe it is. So failure we're talking, whether the failure is severe or it is not severe. So you should know that. Then failure is the taking place, but on what frequency? What is the probability of failure? Whether it is failure is taking place very frequently or whether it is taking place not frequently. And detection risk. So what is the risk involved? Say for example, I take two failure modes. One is failure of chlorine tank, or there is some rupture in the chlorine tank. That is a failure. Similarly, there is a rupture in the oxygen tank. So which is having more risk? So that you have to understand. So failure of oxygen tank is not of much risk because oxygen is a non-hazardous gas. Whereas failure of a chlorine tank is very much hazardous because if you inhale chlorine, if the ppm level is about 100 ppm, 1000 ppm, 1000 parts per million, then even it may take your life away. So what is the risk? That is the thing. So you have to conduct this FMEA. This FMEA is very important because it shows the severity. So how severe it is. So if there is an accident, there is a fire taking place, whether the fire is affecting only a single room or it is affecting the entire building. So that is the severity. And probability, how probabilities. If there is an event which is not at all probable, which is least probable, then why should I focus on that particular event in the beginning? I should always focus on the events which is highly probable or which has the high potential to fail. And also risk. What is the risk involved? So if there is a chlorine tank failure, then the tank is then that is high risk. There is an oxygen tank failure, almost there is no risk. Only the oxygen is going to come out. You can just inhale the oxygen, nothing is going to happen. So you should always focus your activities on these three aspects. So what is the severity, what is the probability, and what is the detection? And this is very important, and such type of activities are carried out in focused improvement pillars. And when you increase this or when you do this, then your overall equipment effectiveness is going to increase. So this is the first time I'm introducing this term, overall equipment effectiveness. So overall equipment effectiveness is the measure of TPM, because any process there should be a measure to know where you are standing. Because if I say that I'm this much weight, only then I can know that whether I'm healthier or not. So there should be some measure. If I say 100 grams of fuel, then how to measure that 100 grams of fuel? So there should be some measuring index. So similarly, overall equipment effectiveness, OEE, is the measure that is available for TPM to know the effectiveness of TPM program. So when you do this focused improvement, then definitely your OEE is going to improve. So based on this OEE, you can know where you are standing and where you want to improve. And moving on to the next pillar, pillar number 5, early equipment management or development management. So both names are available. So early equipment management or development management, basically this pillar, it utilizes all the practical knowledge which have been acquired so far. So because now we are almost all the machines or whatever it may be, we have some experience or some data related to the machine or operation of the machine. So all this practical knowledge and understanding of equipment can be utilized to reduce the breakdown. Say for example, I want to commission a new machine. I want to install a new machine. So before installing the new machine, say for example, I'm getting a lathe from either HMT lathe or some a very renowned lathe. So I can get the information related to the HMT lathe or whatever the brand I'm getting before the installation, and I can reduce, or I can always have the previous experience, so that when the maintenance is needed for this machine, or what is the performance level of the machine. So all data I have. So with that, I can always utilize that particular data. See in this graph, without early equipment management. So this is the place, the MS3 is the point at which the installation or commissioning begins. And MS4 is the point at which the production starts. So the very objective behind early equipment management is, before the production itself, I should do whatever the number of changes in the machine or whatever the alterations I want to do in the machine, so that when the production starts, there is no change in the machine, there is no change in the setup of the machine. There should be minimum setup possible, and there should be minimum scheduled maintenance possible. So this data, or how I can achieve this I can achieve with the learning from the existing system. So you should always be open enough to acquire the knowledge from the existing system. So you should always not say that I'm getting the machine right today, so I will know about the machine from today only. It's not the case. We should always look for the performance of the machine in the previous cases, and you can also have the data, such data, and you can also get the failure data from them. So where and when the machine failed, or where and when the components failed. So accordingly you can plan, and when your machine is installed and your day one production started, you should always have minimum number of changes in the machine. So that is the objective of this early equipment management or development management. And moving on to the next pillar, pillar number 6 is the education and training, which is very important in overall equipment effectiveness, or the focused improvement pillar, which is what I told you. Because you should always train your employees. Only then the employees will know what to do and what not to do. You cannot just employ an employee without telling him anything about the operation, or what to do or what not to do, and you can expect a good return from him. That is never going to be possible. So operators, their skill has to be developed, and the skill on maintenance, especially how to identify a problem, how to identify or how to inspect a machine. All these skills has to be imparted on the operators. And maintenance personnel learn techniques of proactive and preventive maintenance. So the preventive maintenance and proactive maintenance, the maintenance personnel should learn about how to do the proactive maintenance or preventive maintenance. And managers also should be trained on TPM principles, because without any whenever you want to incorporate any philosophy in your organization, appropriate training has to be given. So the training has to take place at all levels, not only at the lower level. Managers has to take the training, even the top management also has to take the training. So managers should know what is TPM and what they are supposed to do. And imparting technological quality control interpersonal skills. So the employee should be imparted with the technical skills and the quality control skills and interpersonal skills also. Because nowadays, when you are working in an organization, your interpersonal skills is very important, because one person cannot do all the things. He has to get the support of his colleague or a person who is working, and he has to have some interpersonal relationship with them. So those skills, everything has to be given in the proper way of education and training, and that is also a key pillar of TPM. And multi-skilling of employees, which is very important for autonomous maintenance, because an operator cannot say, I know only maintenance. So sorry, I know only operation. I cannot do maintenance. Such behavior is not good for the productivity or for small maintenance activities. So the operator should have the multi skill of doing a maintenance activity. So such things has to be given in the form of training. And aligning employees to organization goals, whether you should be clear in defining that this is what organization wants and this is what you are supposed to work for it or work on it. And periodic skill and evaluation and updating and everything. As the world moves, progresses, you're always supposed to improve your skill. You have to evaluate the skill of the employees and you have to update the skill. Only then they'll be ready for the change. And if an old machine is there, you want to change a new machine, the skill level of the operator has to be updated. Otherwise, you will not be able to run the new machine in the organization. So these are some of the key elements of the sixth pillar of TPM, that is education and training. And moving on to the next pillar is safety, health, and environment. And so, as I told you, like 5S. 5S is about your organization's housekeeping. And your organization should also be safe enough for an employee to come and work. The employee should feel confident to come and work in the organization. So that is also very important. And the safety and health working environment pillar, it actually eliminates any health and safety risk in a workplace, leading to a safer workplace. It targets for accident-free workplace. It ensures safe working environment, provide appropriate work environment, appropriate personal protective equipment, eliminate any sort of injury, and provide standard operating procedures. So standard operating procedures is the standard way of operating a machine or doing an operation. So there should be a clear way of doing certain things, because that is what training and education also means. You should train your employees on how to do things. You cannot expect an employee to come directly to you and do whatever you want. You have to have some documents, some operating procedures, and this will help in improving the safety levels of the organization also. And you can see there are people generally work or think about accidents only, but people also should think about a near miss incident. So they have to take it seriously, this near miss incident also, because there may not be a fatality, but a near miss incident is also equivalent to an accident, because only thing there is no person is injured or fatal, just it was missed, that's all. Similarly, whatever the process, whatever the condition, unsafe condition of an equipment, unsafe act by a person, everything has to be taken into account in the health, safety and environment pillar. So generally, generally the safety management principle is like you identify the hazard. So hazard is nothing but which is having some potential to damage. Any material which is having the potential for damage is hazard. You identify the hazard and you assess the risk. So risk is nothing but how potent is that hazard. That's what I told you. Chlorine is a hazard only when it goes beyond certain level. If chlorine is very dilute, it is not a hazard. Chlorine is hazard when it becomes more concentrated. So similarly, you assess the risk. At what point this hazard becomes a risk, and you employ risk control strategies like eliminating the hazard, substituting, engineering controls, administrative controls, personal protective equipment. You give proper personal protective equipment, and you try to implement all these things in your organization so that you can have a good, safe environment for working. And this hazard identification, and this process is a continuous process. You cannot have the hazard, this entire risk assessment process done once and you cannot leave it. It is a continuous process. So for example, when I say you can always this hierarchy of controls is present. First, you try to eliminate the hazard. That is the best possible way. Then you try to substitute with a different material. That is the second thing. Then you employ engineering controls. You try to say, for example, when there is a noise, you try to wear some ear muffler. When there is we are wearing mask, right? We are wearing mask in the COVID situation because elimination of COVID is not possible. The coronavirus is not possible. That's why we are going for different controls. We are wearing mask. We are following social distancing and all those things. So this is the various. So these are the various hierarchy controls, but most effective control is the elimination of the hazard. That is the best way to do it, because once you eliminate a hazard, then you are very much sure that this will not take place again. If you can eliminate corona, then it is very safe for us. That is the simplest example we can have. But since we are not able to eliminate corona, we are going for substitution. We are going for different methods. We are going for controls. We are going for PPEs. We are wearing masks. We are wearing gloves. And those are all comes under the category of PPE. We are following social distancing. That is an administrative work. We are following some standard operating procedure. So that is some procedure to follow. So this and all will not occur when you can eliminate a hazard. So that is the best way is to eliminate the hazard. Similarly, in a work environment also, you should always look for eliminating a potential hazard. And moving on to 8th pillar, the office TPM or TPM and administration. So TPM and administration is like the TPM also can extend to office function also, administrative function also. You cannot always think TPM from the shop floor point of view. You can also think TPM in the office also, because administration also will have some processes which can be considered as a waste, because say for example, unnecessary paperwork is a waste in the office. So you should have whatever the paperwork is required, that you should have. Whatever the paperwork not required, that you should be avoided. So this also can be identified. Your office administration also can be streamlined to reduce the waste, because the administration is also a part of your business, a part of your organization, and your office should be supporting yourself in order processing, because from the shop floor I may give information to my manager that I need this material at this point of time, but if my administration does not process it, does not procure it, then my process is going to stop. So there should be a connectivity between your shop floor and also your administration. And any procedural hazards should be removed. Unnecessary procedures has to be removed in an office. Focus on addressing cost-related issues. So if that's what I told, if there is a paperwork which is not needed, you can just discard. In Pricol, Coimbatore, there was an exercise followed. There was earlier in some 15 years back, they had many forms, say form 1, form 2, form 3, form 4. For many purpose, they had many forms. And one fine day, the management thought we should know what is actually, which forms are used most and which forms are not used. And what they did, they just pasted all the forms on a board, like from form 1 to form 100, you assume. They pasted on the board. They asked each and every employee to go to the board and to just check whether you are using that form or not. And almost 80% of the forms were not utilized by the employees. It was just simply printed. It was just simply stored and it was then discarded. So the management then decided to reduce the number of papers or reduce the number of forms. So this sort of exercise also can be done in an organization to understand to improve the effectiveness in the administration. So these are the basic 8 pillars of TPM, and with this I've just given you a brief introduction about TPM on how the TPM is based on 5S concept and the 8 different pillars. And now we will move on to the measure of TPM, how to measure your performance with respect to TPM. So I told you measurement is always very important. measurement is very important in case of, especially in the quality improvement strategy. So TPM has its own unique measure that is overall equipment effectiveness, and it is simply a product of availability, performance efficiency, and rate of quality. So availability is nothing but how much time your machine is available. So that is simply the availability. You can see the expression also. Availability is nothing but the loading time minus downtime by the loading time. So loading time is the time available for the machine to work. Downtime is the time during which the machine is not working. It can be of scheduled maintenance, it can be of unplanned maintenance, but this is the downtime. Then again, the loading time, the time available for the machine. So it gives you the percentage. So what is the available time? So the availability is going to be from 0 to 1 or from 0% to 100%. Similarly, performance efficiency is nothing but the processed quantity. You can say processed quantity. This is the processed quantity. But what is the quantity that can be processed in that particular cycle time? So that ratio is taken. So if I'm able to run 100 meters in say if I'm able to run 1 kilometer in some 6 or 7 minutes, but there will be some time, right? There will be some time with which there is some standard time that a normal person can run 1 kilometer and so on, so time. So how efficient my process is. So what is the produced quantity with the reference or the theoretical quantity? So that is the performance efficiency. Again, it can be from 0 to 1 or it can be from 0% to 100%. And rate of quality is very simple. Your processed amount, that is your acceptable quantity minus your defect, then your again processed amount. What is the quantity produced? So your acceptable quantity comes in the numerator and the overall quantity produced comes in the denominator. So this gives you the rate of quality. And you understand that it is a product. So even I have a good availability, 95% availability. Again, 95% efficiency, 95% rate of quality. Even I have 95% in all three. But still, when you multiply all these 0.97, 0.95 into 0.95 into 0.95, it becomes 85%. So 85% is the world-class production level. So that is what people say. When you have an OEE score of 85%, it is the world-class level. So to achieve an 85% world-class level, you should have your machine available for 95% of the time. The efficiency of the machine should be 95%, and the rate of quality also should be 95%. Since it is a product, we have this issue. And when you can achieve an OEE score of 95%, then they can say that my rate of my process is world class. And moving beyond 85% is always difficult because it is very easy to improve from 0 to 40 or from 40 to 80. But from moving from 80 to 85, 85 to 90 is always going to be difficult. It's not difficult, it is that it takes real effort and performance to achieve that level. Because in Six Sigma level, Six Sigma level is, when you take the difference between a 4 Sigma level and Six Sigma level, the difference is going to be very small. 5 Sigma level and 6 Sigma level is very, very, very small. But going to Six Sigma level is a really tough job. And when you want to have the performance of 95%, it is always going to be tougher. So when you take this OE, even if you have 80%, 85% of OE, then that is a good score. And measure of TPM, so you can see that availability, performance, and quality are measured, and when all these things are multiplied, the product of availability, performance, quality, it gives the OEE. So availability, your goal is to have no stops. No stops in the sense, no unplanned stops. Planned stops may be there, but unplanned stops should not be there. Performance, again, the machine should run at the optimum speed. There should not be any slow running of the machine, inefficient running of the machine, or no small stops. And quality, no defects. Whatever you are producing, it should be produced without any rework or rejection. So availability loss has to be prevented by reducing the unplanned stops and also planned stops. Performance loss has to be reduced by improving the efficiency of the process, by ensuring you're running the machine at the optimum level. And quality loss should be avoided by ensuring that your products are not reworked or reduced yield. So for 8 hours, you plan for a yield, plan for a productivity, you should be able to achieve that. So these three are the basic elements of this overall equipment effectiveness. And 6 big losses of TPM, as I told you earlier. On the left side, you can see the first 2 columns. In the first column, you can see the 6 big losses of TPM. So unplanned stop, setup and adjustment. So these 2 comes under the category of availability loss. So in the OEE, you can see there is availability, there is performance efficiency and rate of quality. And here also availability loss, performance loss and quality loss. And the 6 big losses, unplanned stops, setup and adjustment. The unplanned stop will occur when there is a tool failure or when there is an unplanned maintenance or some element failing in the machine, overheated bearing or motor failure. It may be anything. These are some examples. So unplanned stop should not occur. If this loss occurs, it is affecting the availability. It is reducing the availability of the machine. Then setup and adjustments. Again, when there is a changeover, when there is a tool changeover, or when you're changing the setup for a different specification of the product, you should do it within the shortest minimum period of time. So that's what here this SMED procedure comes into picture. So a single minute exchange of die, so single digit minute of exchange of die. So within 10 minutes, you should be able to change all your setups. So if you exceed this time, then the setup and adjustment will lead to availability loss. So these 2 losses will reflect in the availability of the machine. Then coming to the performance loss, you can see the next 3rd and 4th loss, small stops and slow running. Small stops are nothing but there may be some component jamming or some minor adjustment, sensor blocked or not working properly, delivery blocked, cleaning or checking. So these require small stops. Then slow running. Slow running is you may not set up your machine properly, you may not align your workpiece properly. So incorrect setting or equipment wear. So as the equipment wears, there may be reduction in the efficiency, because in a machining operation, if you take the single point cutting operation, the machining, the surface roughness, surface quality will be good until the cutting edge is very sharp. When the cutting edge starts to wear, the surface roughness is also going to increase. So similarly, you can have the effective period for a machine. Only there is a specific window. So that window you try to achieve. So slow running or loss of performance has to be reduced. And the 3rd loss is the quality loss. So the quality loss, the big losses are under the quality loss is the production defects and reduced yield. So when you produce with the defects, either you want to rework or you scrap it. And yield, for a certain period of time, you should produce what you're supposed to do. If you are reducing the quantity produced, then automatically your quality is also going to get reduced. So these are the 6 big losses: unplanned stops, setup and adjustments, small stops, slow running, production defects, reduced yield. And these things can be overcome by implementing all the 8 pillars of the TPM. And most of the losses are overcome by just implementing the autonomous maintenance pillar, focused improvement pillar, and quality maintenance pillar. By these three pillars alone, there is a significantly you can reduce all these losses. That is what generally you can find out in many of the experiences of the real practitioners of TPM. When you read papers on TPM, people will mostly focus on autonomous maintenance and more specifically on the focused improvement. So these two are very critical pillars of TPM. And now this is how the overall the framework of TPM, how it works. So basically we saw the 8 pillars of TPM, which is based on the 5S concept. So 5S is the foundation for TPM, and you have 8 pillars of TPM. And after 8 pillars of TPM, we saw about the measure of TPM, how we are measuring the TPM. So because any quality program should have some indication. So how we are measuring and what are the 6 big losses in TPM. So these things we discussed in this particular part. The third and final part, we will discuss about a step-by-step roadmap or a simple and practical TPM implementation. So by now, I think you'll be able to appreciate how this TPM is going to relate with lean manufacturing. Because as I told you earlier, lean is about reducing the waste. TPM is more focused on reducing these 6 big losses. And these 6 big losses are a waste in a manufacturing organization or in any organization. So this 6 big losses reduces the waste, and thereby this this TPM paradigm is contributing towards the lean manufacturing. So now we will see a small roadmap or a simple roadmap. It's like more like a example, not a real case study or what we have seen in real time. It is just like an example about the implementation of TPM, a simple and practical implementation. And so first, step 1, you have 5 steps in this. We will discuss about 5 steps here. And step 1, you should always identify the area where you want to improve. You want to identify the area or the machine which you want to improve. So basically, you try to identify the equipment which you want to improve. So something I have marked in green color. So it is always, you should focus on the bottleneck operations, because bottleneck operations always, it readily increases the output and it gives the quick payback time. Whereas when you go for the easiest to improve option, because in the Pareto analysis, I told you, 1 or 2 problems will contribute significantly, whereas 10 or 15 issues will contribute only to a less thing. So you should always focus on the critical issues, not on a very easy to, a simple problem. If you take, you can easily overcome the problem, but what is the payback? You're not getting the enough payback. So initially you should focus on the activities which are considered to be the bottleneck or the constraints. Even sometimes most problematic also you should try to avoid, because most problematic issues will require some time to solve. So that time you cannot lose it just by focusing on one single problem. So it is always better to choose a bottleneck problem, and you work on the bottleneck problem. You try to improve the bottleneck problem. Then later on, you can go for the most problematic and the easiest to improve issues and whatever the issues may be. So as a whole, you should think that initially you should work on a problem which is the critical part of your process. So that particular problem you should work. So that is the step 1 of your TPM implementation. So you should identify the right problem or the right target equipment for implementing the TPM. And step 2, initially step 2 is concerned with 2 things. One is you are implementing 5S and also you are implementing autonomous maintenance. Because I told you TPM is always going to be based on the 5S concept. When you have good housekeeping procedures, when you have good housekeeping in your organization, it is always easy to identify the issues. It is always easy to solve the issues. So first, if I go for, before going to the maintenance activity, I need to look into my workplace. I need to just take a photograph. If the workplace is messier, if it is not proper, I will take a photograph of the initial state of the equipment. I clear the areas, I clear the area of the debris, unused tools, unused components, and I organize. So tools and components, everything are organized in such a way that I should be able to retrieve the tools when I need it and clean up the equipment, surrounding area, take a photograph. So you compare your original photograph and your new photograph, and you ensure that you always ensure that this is the way your workplace has to remain. You record it, you create a standard operating procedure for that. And so whomever the operator comes, first he will do all these housekeeping procedures. Later he will start to work on the machine and create a simple 5S checklist for that particular area. You create a simple 5S checklist. So what are the things to be done? Then you do the auditing, you do auditing for the sake of sustaining the improvement, whatever you have made. So in that way, this step 2, restore the equipment to prime operating condition. It is having 5S. The 5S is applied initially. Then you go for the autonomous maintenance. Autonomous maintenance, you can see, you try to identify the inspection points. So what are the parts or what are the areas of the machine inspection has to be done. Then visibility, whether you need an opaque guarding or transparent guarding. So all these things can be decided on by the teams. Then set points, lubrication points. So set points and the thing, what are the initial setups or conditions to be done. Lubrication points, where to lubricate and where not to lubricate and how to lubricate. All these instructions has to be followed. Then operator training, train the operators for all these autonomous maintenance. Again, create a checklist for autonomous maintenance. So when an operator comes to this machine, first he has to check, then he has to clean, then he has to inspect, then he has to check for lubrication. So like this, you create a checklist. Then finally, for sustaining this thing, you do an audit. So a manager will come and he will frequently check whether these things are done. So first you try to restore the equipment to the prime operating condition. That is very important. Then step 3, you are starting to measure your overall equipment effectiveness, because I told you overall equipment effectiveness is a measure of TPM, and this overall equipment effectiveness has to be measured frequently, like how much you are losing in availability time. So your machine should be available. So availability lost time, you can see 34 hours are lost in the last 7 days. So this is a small data. So last 7 days, 34 hours are lost. That is a huge time. The performance lost time, 27 hours. And quality lost time, 3 hours it is lost in reworking or 3. So such type of OE, this availability losses, performance losses, and quality losses has to be measured. And you can also have the OE, live OE recording taking place. And you should know which processes are creating the issues. So you have to target those specific areas. So you measure the OE, you should know whether the problem is in availability or whether the problem is in performance or whether the problem is in quality. So then you go for, in availability, you have to look for the two losses. Performance also, you have to look for the 2 losses. Quality also 2 losses. So which loss is taking place more? So you have to target that and you have to work for improving the OEE. Then you come to the step 4. Now here it is more like a focused improvement. It is the pillar of focused improvement. So step 4 is overcoming the 6 major losses. So for overcoming the 6 major losses, your focused improvement pillar is actually the key pillar. So as I told you in the focused improvement pillar also, and again I'm repeating the same, focused improvement pillar is very much essential in the TPM paradigm. So you have to know where you are starting. You need to know where you are losing time or where you are losing the performance. So based on the OEE data, you should know where the loss is taking place. And once you understand the loss, based on the loss, you create a cross-functional team. You create a cross-functional team with employees like operators, maintenance personnel, supervisors, everyone are put in the team, and they will work on the problem, and they will collect the data. They will collect what is the problem and how the problem is occurring, what are the potential causes, what based on the available data. Because when you see a problem, you will know the data.
Hello,
and
sir.
some other issues. Hello.
Sir, it's a reminder that we have to another 5 to 10 minutes to conclude the session, sir.
Yeah. I'm just on time only. No issues. I'll be completing it at 4:15. No issues.
Yeah. Okay. Thank you.
So you create a cross-functional team. Then you include the operators, maintenance personnel, supervisors, everyone in that cross-functional team. Collect information on the equipment failure, equipment data, everything, all data you have. So based on that, you create the fishbone diagram or whatever the quality tool is very much suitable here. So as I told you, you are not focused, you're not confining yourself with only certain tools. You can use any tool which is suitable for that particular situation. You use the tool, you try to identify the real cause for this problem, then you try to overcome the problem by taking solutions, by implementing the solutions with the help of the cross-functional team. Then as this occurs for a few times, so you will try to develop a practice. You will try to develop a pattern for you, so that this machine, so this is the problem, these are the problems that is going to occur, and these are the frequency it is going to occur, so that at this instant I'm going to implement all these control measures. So in that way you can reduce the 6 major losses. And step 5, then introduce the proactive maintenance. So again, as I told you earlier, in one specific case, you have to divide your points, you have to divide your components in 3 different ways: the components that wear, components that fail, and the stress points. So components that wear, you should know, you will have the lifetime. You will get the lifetime of the component from the manufacturer, or by practice also you will know. So according to the lifetime, according to the data, you can just replace the component. And component that fail, again, you will know the reliability data of the components. You should have the reliability data. So based on the reliability data, after a certain period of time, you can change the component. Similarly, stress points. You should, again, even though you have the data, you should always monitor the process also. You should monitor for the temperature. You should monitor for the vibration. You should monitor for any other unwanted behavior of the machine. So these things comes by practice to most of the operators. And also you can utilize different sensors, temperature sensors, vibration sensors. You can use such sensors to monitor the machine. And if any abnormality is occurring, you can take a call on that. And after you identify, you give the solution. So based on wear, I need to maintain autonomous maintenance. Then predicted failure based. So based on the failure, I can go for planned maintenance schedule. And so these are the ways I can create a proactive maintenance interval. So wear based components, I have a separate maintenance interval. predicted failure. I know that this failure is going to take place at that point of time. I have a separate maintenance chart for that. Then time-based. So after a certain period of time, it is a combination of wear and failure. So after a certain period of time, no matter the product has worn out or not, I just do the maintenance for a safer side. So that sort of strategy also can be followed. Then create a standard process for generating work orders based on the planned maintenance. So you create that this is your standard process. So with all the resources, this is my capacity. You create that trend, and based on the trend, your company can work or can predict of your productivity. And then feedback system is very important. And so what are the maintenance activities? You have to log it, you have to record it for further future investigation or future use. Then monthly audit has to be conducted. Monthly audit is very important because whatever you have planned, whether the plan has gone without any deviation or not. So all these things has to be taken place, audited during the monthly audit. The maintenance interval adjustment. So based on experience, initially we may say that this is the time for maintenance. Later, by experience and by operators, by the way of operating your equipment, we can reduce the time for maintenance interval also. Sometimes what you have predicted, the maintenance interval may be more also. So in that way, you can do small adjustment to your strategy, and you can carry out all your maintenance activities as per the developing or this continually developing strategy. Another TPM activity, quality maintenance, early equipment management, safety, health and environment, TPM and administration. So also very important because, but other than this, the autonomous maintenance, focused improvement, then planned maintenance, these are the very critical TPM pillars you want to focus. Whereas these maintenance activities are a part of the quality maintenance is also a part of focused improvement. Whereas early equipment management, only when you install the new machine, this is going to come into picture. Safety, health and environment. Safety and health and environment is a separate division. In any organization, they should have a separate safety officer. They should have a separate safety system, but they will work in a complementary manner to one another. Then TPM and administration is also very important because any procedural delays, office delays has to be reduced. So in this way, this is just a small roadmap of how to identify, how to step by step implement your TPM in an organization. First, you choose the process, which is the critical process, that is the constraint or bottleneck. Then second, you implement 5S and autonomous maintenance. These two are the basic pillars. If you can implement these two, then it is always it is better to start from these two. And then you measure the OEE, you know where you are losing time, whether you are losing the availability, losing the performance, or losing the quality. You can understand, accordingly you can focus. Then 4, you should create a focused improvement. So 5S, autonomous maintenance and focused improvement, another key pillar. Then 5th, you can strategize yourself based on the components that wear, based on the components that fail, based on the components requiring continuous monitoring. You can strategize yourself, and accordingly you can work to overcome or to plan the maintenance intervals. And so this industry 4.0 scenario is still applicable, this TPM. So industry 1.0, industry 2.0, industry 3.0, and now we are in industry 4.0. And the circle which is present on the right side gives all the activities of industry 4.0, shows the industry 4.0 activities. And in any of the activity, you have always the scope to reduce waste. And the TPM is always a good method to reduce the waste in an organization or in any process. But I don't want to go much into industry 4.0 because we have few other sessions also coming up. But today's session is purely focused on how lean manufacturing can be achieved through TPM. And with this, I complete my presentation. So, is there any queries, or the session is? I thank the organizers for giving the opportunity, and I thank all the listeners for listening with patience. So, I once again thank the organizers for and ATAL scheme, ACTE, the management of Rajarajeshwari College of Engineering, and Professor Karthikeyan for giving me this opportunity. So, any discussions we'll have tonight.
Thank you very much, sir. Just to sum up the session, just I will enumerate some of the links on which Dr. Sir has given elaborate information on this lean manufacturing. Sir started with the definition for the lean manufacturing, that is just-in-time manufacturing. And he has given a good example of Toyota production system, which is started in Japan, and some of the methods in lean manufacturing system. And he has discussed on total productive maintenance and the 5S foundation consisting of 5 elements, and the elaborate information on 8 pillars of TPM activity and measures under the TPM, and 6 big losses we have to more concentration. And he has explained the roadmap for TPM implementation. So thank you very much, sir. So on behalf of Rajarajeshwari College of Engineering as a host institution coordinating this, ACT sponsored ATAL Training Learning Academy, ATAL Academy, on 5 days online faculty looking program on lean manufacturing industry 4.0 scenario. I thank the speaker and all the participants for joining this session.
So all the participants, please switch on your camera. We'll take one group shot for documentation purpose to have to submit to the ACT. So please, all of you, enable your camera. Please, all of you, enable your camera.
Sir, you enable camera from your side. It's disabled.
Okay, sorry. Okay, just one minute, I'll enable it. So this is how to do it.
Our camera is not open.
You ask, go to permissions.
Now the participants can switch on their video camera.
Oh, still not possible.
Sir, can't open the video, sir.
Yes, sir, please, sir.
Try to change the setting.
Sir, you go to permissions. There you can.
A host has to permit. It shows like.
Yeah, host only.
Yeah. Now you please check.
Now it is possible.
Yes,
Yes.
sir.
How it is okay.
Next to all.
We'll take one by one. I'll take the 4 screens. I'll take first screenshot. The second screen. The first screen only members are switch on the camera. Okay, let's leave it. Okay, thank you, Professor, for your wonderful participation. So tomorrow also let us join at for 8:55. Okay, thank you, sir.
Thank you, sir. Thank you for the opportunity.
Thank
sir.
you, one and all.
Okay,
Thank you, the speaker for the session.
Thank
Dr.
you so
N. Shivam,
much.
sir.
Thank you. Ray.
Thank you, one and all.
Thank you, sir.
Formally, we close the session of day one. So please share your feedback and as well as an attendance. Thank you all.
Sir, Karthikeyan, sir. Thank you, sir.
Yes, sir. Thank you, sir. Thank you.
Okay, sir. Okay, sir.
Thank you. Ray.
Thank you, sir. Meeting
We'll
end பண்ணிக்கிறேன்,
close
sir.
it. Yes, sir. Thank you.
Okay, sir. Okay, sir. Thank you, sir. Thank you, sir.